In this video, we're going to look at some examples of integration by substitution. So the first integral is x times the square root of 2x plus 5 dx. So in this case, they're going to make a specific substitution saying that u is equal to 2x plus 5. So what we're going to do is we're going to find the derivative of this. So we can say du by dx is equal to 2. And therefore say du is 2 times dx, and that a half du is equal to dx. So I can put a little subsection here called substitution and state exactly to the examiner what's going to be substituted. So I can see that the square root of 2x plus 5 is exactly the same thing as 2x plus 5 raised to the power of a half. Well, that's going to be u to the power of a half. Then I know that dx is going to be substituted with a half du. But the issue is, what about this x? What's that going to be substituted with? Well, if u equals 2x plus 5, then I can change the subject of a formula and say, well, x is going to be u minus 5 over 2. Now, I could rewrite that as a half times u minus 5. So in my substitution section here, I'm going to say, well, x is going to be substituted with a half multiplied by u minus 5. So we're going to replace everything in the integral. So I'm going to write the original integral out here. So the integrand is the integral of x times 2x plus 5 all raised to the power of a half dx. That's the original integral. Now we're going to substitute everything with what we have. So it now becomes a half times u minus 5. That's what x is. 2x plus 5 raised to the power of a half now becomes u to the power of a half. And we said that dx now is a half du. So the integrand now becomes a quarter times the integral of u to the power of a half times u minus 5 du. So we can simplify that down to be a quarter. Now expanding the brackets, u times u to the power of a half is 1 plus a half is u to the power of 3 over 2 minus 5 times u to the power of a half du. So what happens now is we can integrate that. So leave the quarter on the outside. So I get, adding 1 to the power, I get u to the power of 5 over 2 divided by 5 over 2 minus 5 times u to the power of 3 over 2 divided by 3 over 2 plus the arbitrary constant. Then what happens now is I will get a quarter times the following: 2/5 times u to the power of 5 over 2 minus 10 over 3 u to the power 3 over 2 plus the arbitrary constant. Multiplying everything by a quarter times 2/5 will give me, if I do that in full, I will get 2 over 20 u to the power of 5 over 2 minus 10 over 12 u to the power of 3 over 2 plus c. And therefore we're going to do a simplification. So we get 1 over 10 u to the power of 5 over 2 minus 5 over 6 u to the power 3 over 2 plus c. If we go back to our substitution, we said that u was 2x plus 5. So I'm going to make that substitution in here. So I'm going to say we're going to replace the u with 2x plus 5 raised to the power of 5 over 2 minus 5 over 6 times 2x plus 5 raised to the power 3 over 2 plus c. Now, the next case is when we have the same integral, but now they say that the substitution is going to be u squared is 2x plus 5. So we're going to rewrite the integral as x times 2x plus 5 raised to the power of a half dx respectively. Now, in this case, we're going to use implicit differentiation. So we're going to say 2u du by dx is equal to 2. The 2's cancel out. So u du by dx equals to 1. So u du is equal to dx. So if I make a little substitution section here, we can say, well, we can see that 2x plus 5 raised to the power of a half will be exactly u. And we can say that dx is going to be u du. But we don't have a substitution at the moment for x. But if we write u squared equals 2x plus 5, what we can do is change the subject of a formula there as before. So we can say u squared minus 5 divided by 2, which is exactly the same as a half times u squared minus 5, will be equal to x. So x is a half times u squared minus 5. And we can add that in our substitution section. So x is a half times u squared minus 5. So we can now put this in our integral. So I'm going to write the original integral out so you can see what it was. So it's the integrand is the integral of x times 2x plus 5 raised to the power of a half dx. And the integrand now becomes, we said that x was half times u squared minus 5. 2x plus 5 raised to the power of a half we said was u, and we said that dx, going back to our substitution section, was u du. So we're going to write that in times u du. Now we can tidy up this integral, take the constant outside the integral. U times u is u squared times u squared minus 5, and then we get a du. So that gives me a half times the integral of u to the power 4 minus 5 u squared du. Now what happens is we can integrate this. So you get a half on the outside, we get a fifth of u to the power 5 minus 5 u cubed over 3 plus the arbitrary constant. And then if we multiply the brackets out here, we're going to get a 10th u to the power 5 minus 5 over 6 so minus 5 over 6 u to the power of 3 plus the arbitrary constant c. But what was u? We said that in our substitution u was 2x plus 5 raised to the power of a half. So it's going to be 1 over 10, 2x plus 5 raised to the power of a half, all raised to the power of 5 if you like, minus 5 over 6, and then we've got 2x plus 5 raised to the power of a half, all raised to the power of 3, plus the arbitrary constant. And then we can simplify that down to be 1 over 10, 2x plus 5 raised to the power 5 over 2 minus 5 over 6 times 2x plus 5 raised to the power 3 over 2 plus the arbitrary constant c.